the second lecture of Ionic Equilibria. Now we are going to discuss about weak acid in this, right? Let's talk about weak acids. If you talk about weak acids, so I have an example for you. If you talk about weak acids, so one of the weak acid we have is HNO2. This is one of the weak acid, right? So whenever this acid is going to dissociate into its ions, so it will be going to produce H positive ions and NO2 ions, right? ये आपके पास क्या होगी equation बनेगी. And we know that weak acids are acids that dissociate partially. So this is always partial dissociation. This is always partial dissociation because these are actually weak acids. They are going to produce less ions, right? So what will be the Kc equation for this? If you talk about the Kc equation, we know that Kc equation is always the concentration of product over the concentration of reactant. So according to this concept, if you talk about the expression, so it will be H positive ion की concentration into NO2 ions की concentration over the concentration of HNO2, right, बच्चों?
Yes, sir.
Right. So it is always like this, or if you want to write a general dissociation equation, just want to write general dissociation equation, so it always be like कि आपके पास क्या होगा, आपके पास for suppose कोई भी acid होगा, it is going to dissociate into H ions and anions, right? It will be always like this, and the Kc is always the concentration of ions over the concentration of acid, right, Bacho?
Yes, sir.
Now, you need to understand this. We talk about this in the last class that the liquids have fixed concentration or constant concentrations, right? So HNO3 is a liquid over here, which is right now working as an acid over here. Weak acid, its concentration is always fixed over there. So definitely we can send this constant towards the Kc. Kc की तरफ आप concentration of HNO2 को send कर दीजिए. So the equation will be like H positive ions into NO2 ions. Now these are two constants, so I am just combining these two constants to produce one new constant, and it is what? Ka. This is what? Ka. This is what? New constant for you. This is the constant for weak acids. This is the constant for weak acids. So you can say that Kc of weak acid. You can even say that Kc of weak acid is Ka. Is Ka. Is that right, बच्चों?
Sir, HNO2 liquid था.
HNO2 आपके पास जो है यहाँ पर solvent है, right?
तो सर KW तो आपने बोला था
KW
दो
तो water की dissociation, KW तो water की dissociation है ना?
अच्छा, ओके सर.
ये किसकी है? ये आपके पास dissociation है किसकी? ये dissociation किसकी है आपके पास? ये acids की है, ठीक है?
ओके सर.
चलो, this is the case that you need to understand, right? तो ये हो गया आपके पास weak acid, ठीक है? अब इसकी एक एग्जांपल करते हैं. जब आप इसकी एक एग्जांपल करेंगे तो for suppose we have 25 degree centigrade. We are talking about the normal temperature, right? Room temperature. At this temperature we have a pH of 2.20, right? This is one of the pH, and we need to find out Ka. We need to find out what? Ka. And whatever the acid we have, the concentration of this acid is actually 0.1 mole per decimeter cube Ha. कोई भी acid हो सकता है, Ha, ठीक है ना? We know that whatever the Ha, when it dissociate, it will dissociate into H ions because of acid, right? And one anion over there. So the Ka equation if you want to write Ka equation or if you want to write Kc equation, so you can even say that Ka will be H positive ions and negative ions, right, बच्चों?
Yes, sir.
We don't know the concentration of H. We don't know the concentration of H, or even we don't know the concentration of anions, right? और दूसरा ये कि even over here, if you want to put concentration, so you can put concentration of HA over here because it is given, it is constant. You can even put over there. It is given to you, so you can even put over there as well. But right now we don't have. We have the concentration of this, but we don't have the concentration of this and this, right? Now, how can we find out Ka when we don't have this? These two values. There are two x, right? पिछले क्वेश्चन में हमने क्या किया था? हमने h को अगर x सपोज किया था, तो a को हमने x सपोज कर लिया. That was fine because जब कभी भी आपके पास वाटर डिसोसिएट होगा तो इक्वल आयंस डिसोसिएट होंगे. दैट्स फाइन, हम उसको सपोज कर सकते थे. बट यहाँ हम सपोज नहीं कर सकते क्योंकि दिस इज अ वीक एसिड. Whenever you talk about weak acid, so there is a partial dissociation. We don't know how much dissociation will be occur, so that is why we cannot consider x over here. तो हम क्या करेंगे भाई? हम pH के थ्रू जाएंगे. हम pH के थ्रू कैसे जाएंगे? pH is actually 2.2. We know this. We know the formula of pH as well. pH is actually negative logarithm of H positive ions. We know this, right? तो अब हम क्या करेंगे? अब हम इसमें वैल्यू पुट करेंगे, राइट? इसमें वैल्यू क्या पुट करेंगे? हम इसको कन्वर्ट कर सकते हैं. पहले हम इन दोनों को अगर इनका एंटी लॉग ले लें तो इट विल बी व्हाट? इट विल बी 10 की पावर माइनस pH और इट विल बी व्हाट? इट विल बी H पॉजिटिव आयंस. ऐसे ही हो जाएगा लॉग लेने के बाद, एंटी लॉग लेने के बाद बच्चों. ऐसा हो जाएगा.
Yes, sir.
And we know the pH. What is the pH? pH is minus 2.2, right? So it will be this, right? So if we solve this, so the answer will be, what will be the answer? The concentration of H ions will be 6.31 10 raised to the power minus 3, right? This is what the concentration of H ions. Once we are able to find out the concentration of H ions, now we can find out Ka. You can put these values over there. Ka, whatever the concentration of H ions, definitely the same concentration of anion as well. So this is the concentration of H ions and also the concentration of anion same. So it will be 6.31 10 raised to the power minus 3. Now you can even use a small bracket as well over there, right? And what is the concentration of acid over here? It is 0.1. When you solve this, the value of Ka, this will be 3.98 10 raised to the power minus 4. ठीक है ना? ऊपर आपके पास 2 मोल पर डेसिमीटर क्यूब है, नीचे भी आपके पास 2 मोल पर डेसिमीटर क्यूब है. When they will be like एक दूसरे से कैंसिल होंगे तो आपके पास ऊपर बच जाएगा 1 मोल पर डेसिमीटर क्यूब. So this will be the unit of Ka, right बच्चों? That right?
सही समझ तो आ गया, लेकिन ये कैलकुलेटर में जो लॉग है वो एंटी लॉग कैसे होगा?
आपने कन्वर्ट करा ना उसको, आप उसका एंटी लॉग निकाल रहे हैं. लॉग को खत्म करने के लिए हम एंटी लॉग लेते हैं, ठीक है? लॉग को खत्म करने के लिए आपको एंटी लॉग लेना पड़ता है. तो हमें चाहिए था H का आंसर, तो हमें उसको खत्म करना पड़ा, ठीक है ना? हमारे पास pH गिवन थी तो इसलिए हमने लॉग का एंटी लॉग लिया, तो इट विल बी कन्वर्टेड लाइक दिस, ठीक है ना? उसके बाद हमने वैल्यूज पुट करके निकाल लिया, ठीक है? यू हैव कैलकुलेटर, यू कैन गो थ्रू दिस. अगर आपका आंसर सही आ रहा है तो ठीक है, अगर नहीं आ रहा तो मुझे बताएं, मैं आपको बता देता हूँ कैसे कैलकुलेट करें.
सर आ गया.
आंसर सही आ
जी यार.
अगर आंसर सही आ रहा है तो ठीक है, अदरवाइज नहीं आ रहा तो आप मुझे बता सकते हैं. बच्चों आप लोग ये लिख सकते हैं. जस्ट डू इट क्विक, फिर हम इसकी दूसरी एग्जांपल. नेक्स्ट क्वेश्चन क्या है बच्चों हमारे पास? द नेक्स्ट क्वेश्चन इज फॉर एग्जांपल वी हैव कार्बोक्सिलिक एसिड, we have ethanoic acid. We know that we did this in O levels as well, that ethanoic acid is a weak acid, right? For suppose we have CH3COOH, this is what? Weak acid. So when this dissociates, it will produce what? CH3COO ions and H positive ions. ठीक है ना? For suppose I just give you the concentration of CH3COOH as 0.1 mole per decimeter cube. Right? This is what the concentration you have. What you need to find out, bachcho, you need to find out pH. You need to find out what? pH. If the value of Ka is given to you, the value of Ka is 1.79, 10 raised to the power of 5, right? Minus 5. And the unit is mole per decimeter cube. Right? So how can you find out the pH of such questions in which the Ka is given and the concentration is given? Now it's very easy. We can write the equation of Ka. It will be what? Ka will be concentration of product, right? Or concentration of reactant. This is CH3COOH, right? Then we just need to put the values to get the answer, right? What is the Ka? It is 1.79 and raised to the power minus 5. Okay, and we know that whatever the dissociation, पूरी हो, आधी हो, 75% हो, 25% हो, जितने H ions टूटेंगे उतने ही आपके पास ethanoate ions भी टूटेंगे, right? And this is we already have, right? So it will be 1.79 into 10 raised to the power minus 5 into 0.1 is equals to x square, right? If you want to find out the value of x, so you can take square root of this 0.1 into 1.79, 10 raised to the power minus 5, right? So what will be the value of x? You will have the value of x as 1.34, 10 raised to the power minus 3 mole per decimeter cube. Once you have the concentration of H, then to find out the pH is not a big deal for us. You can simply find it out as pH is actually negative logarithm of H positive ions, right? So pH will be negative logarithm of H positive ion 1.34 10 raised to the power minus 3. pH will be 2.87. pH will be 2.87, right? The pH will be 2.87, right, बच्चों?
Yes, sir. जब हमने H पर minus pH is equal to minus log H positive ion, तो ऊपर हमने एंटी लॉग क्यों लिया था?
एंटी लॉग हमने इसलिए लिया था ना क्योंकि उस वक्त हमें pH गिवन थी और हम H आयंस की कॉन्सेंट्रेशन निकाल लेते हैं. अभी हमें H आयंस दिए हुए हैं और हम pH निकाल लेते हैं.
ओके,
पहले उल्टा था, राइट?
यस.
ठीक है बच्चों, अब एक चीज और इसमें मैं ऐड कर रहा हूँ. आपके पास एक और चीज क्या होती है? एक चीज आपके पास होती है, जैसे आपने pH सीख लिया, pOH सीख लिया, एक चीज आपके पास होती है pKa. एक चीज क्या होती है आपके पास? pKa. What is pKa? It is actually negative logarithm of Ka. It is actually what? Negative logarithm of Ka. So K is already given to you, so you can even find out pKa as well. pKa value, right? pKa value भी निकाल सकते हैं आप. Negative logarithm of Ka की वैल्यू कितनी थी आपके पास? 1.79 10 raised to the power minus 5. तो आपके पास pKa वैल्यू कितनी आ जाएगी आपके पास? It will be 4.75. This is one more thing that you need to understand. And for your kind information, you need to keep remember the note over here. This will be the note. For suppose आपको दे दिया गया, आपको pKa वैल्यू दे दी गई और आपको निकालनी है Ka. For suppose आपको pKa वैल्यू दे दी गई और आपको निकालनी है Ka, तो आप कैसे निकालोगे? एंटी लॉग के जरिए निकाल सकते हो आप, और यहाँ पर आपके पास आ जाएगी वैल्यू pKa की. ठीक है ना? इसी तरह जैसे अभी हमने किया है H की कॉन्सेंट्रेशन निकालने के लिए हमने एंटी लॉग लिया था किसका? pH का. Now this will be the note for you. You need to keep remember this. It is very important to know. सही है बच्चों?
Yes, sir.
Let's talk about further, right? Let's talk about further about this. We are talking about what? We are talking about pH. How can we find out pH? So we know that how can we find out pH? It's very easy. You all did this very well, mashallah. आप सबका आंसर बिल्कुल ठीक है. ठीक है, मैं आपको एक बार और करके दिखा देता हूँ कि अगर किसी का आंसर गलत आ रहा होगा तो चोरी छुपे उसकी हेल्प हो जाएगी. ठीक है ना? हाउ कैन वी सॉल्व दिस बच्चों? वी नो दैट जब कभी भी आपके पास ये ब्रेक डाउन होगा तो व्हाट विल बी द Ka वैल्यू? इट विल बी द कंसंट्रेशन ऑफ प्रोडक्ट, right, over the concentration of reactant, right? This is what we need to understand, and we know that what is the Ka right now? It is 4.43 10 to the power minus 4, and this is X, we don't know, right? And HNO2 is 0.375. So we can find out X by taking root over there, right? Ka की जो value है उसको हम multiply करा देंगे concentration से, and the value of X कितना है बच्चों आप लोगों के पास? 0.0128 I think, है ना? उसके बाद you can find out the pH.
Yes,
negative logarithm of H positive ion. इसमें आप H positive ion put करोगे तो आपकी pH कितनी आएगी बच्चों? 1.89. कितनी आई है?
Yes, sir.
So this is what the pH, right? ये आपके पास इस क्वेश्चन की pH आ गई है. Now let's talk about something more about this chapter. So for suppose if you have any ionic compound, for suppose मेरे पास होता NaNO2. मेरे पास क्या होता बच्चों? NaNO2. अगर मेरे पास NaNO2 होता तो this is actually ionic compound, तो ये partial dissociate नहीं होता, ये complete dissociate हो जाता. ये आपके पास complete dissociate हो जाता. तो you need to keep remember कि ionic compounds dissociate completely. Ionic compounds dissociates completely, right? You need to keep remember this. So when they dissociate completely, so definitely they will produce more ions over there. If you focus over there, HNO2 आपके पास dissociate हुआ, आपके पास HNO3 था 0.375 mole per decimeter cube, and you will have what? You will have 0.0128 concentration of NO2. 0.3752 था तो 0.0128 concentration आपको मिली NO2 की, right? For suppose अगर आपके पास NaNO2 0.1 होता, अगर ये 0.1 होता ना आपके पास, तो आपके पास NO2 भी 0.1 ही बनता. This is the difference between ionic compounds and acids, weak acids, right? So weak acids dissociate partially, while the ionic compound dissociate completely, or you can say that the strong acid also dissociate completely. So you can say that, bachcho, what you can say that? You can say that okay, adding of salt, right? We talk about adding of salt in the same system, adding of salt in the same system will increase the concentration of anions, right? Adding the salt in the same system, this process क्या करेगा आपके पास? Increase the concentration of anions, right? Increase the concentration of NO2 minus 1 over there. ठीक है भाई? So you just need to keep remember if you talk about reversible reaction. So right now you have, for suppose HNO2, right? This is a reversible reaction. It is breaking down and producing H positive ions and NO2 negative ions, right? This is a reversible reaction, and you are adding salt over there. You are adding NaNO2 over there. So when it dissociates, it will completely produce sodium ions and NO2 ions. So definitely sodium ions are not going to affect the equilibrium over there, right? But NO2 ions, right? आपको पता है कि अगर आप NO2 ion concentration को increase करोगे, if it increases, तो आपके पास reaction कहाँ चला जाएगा? इस तरफ चला जाएगा, right? So you need to keep remember this. You are increasing the concentration of NO2 ions, तो वो left hand side पर आपके पास चला जाएगा reaction, ये reversible reaction है, right? So you can say that it shifts, adding increase the concentration of NO2, it shifts the equilibrium toward left hand side. It shifts the equilibrium toward left hand side. It will shift the equilibrium towards left hand side. Hence, you can say that the acidic behavior will be lesser. Definitely the acidic behavior is due to the H positive ion, right? Acidic behavior is due to the H positive ion. So when the H positive ion are going to be lesser from the container, so definitely the acidic behavior will be decreases. So you can say that H positive ion concentration decreases, then acidic behavior decreases. Right, bacho? And
Yes, sir.
pH rises. pH ऊपर की तरफ जाएगी. pH कहाँ जाएगी बच्चों? ऊपर की तरफ जाएगी. So let's see in the calculation. Let's see this. क्या होता कैसे है ना? Calculation में अगर हम इसको करें, so we know that Ka is what? Ka is actually the concentration of H ions and NO2 negative ions over HNO2. This is the Ka. That's fine. We know that the Ka is 4.43 10 raised to the power minus 4. That's same. We know that. We don't know X, right? And this is what? 0.375. It is fixed. So the value of X that we have previously is 0.0128, and the pH previously we have 1.89. That's fine. We already did this, right? पिछला वाला हम ये कर चुके हैं. Now, after adding salt, जब आप salt add करते हो, so what is going to be happen? If you add salt, so Ka will remain same, H ions are same, concentration is same, but also the concentration of NO2, you know, is 0.1 already over there. 0.1 is already over. बेटे एक मिनट दीजिएगा मुझे जरा. क्या कर रहे थे हम लोग? Just talking about this one. So if you don't, sorry for the disruption. Actually मेरे बेटी के आँख पे लग गई, वो रो रहा था और उनको बाबा ही चाहिए और बाबा से भी बात नहीं बनी तो वापस चले गए. खैर, so it is actually we are talking about what? We are talking about after the addition of salt. So this is what we need to understand. सबसे पहले हम जल्दी से H ion की concentration मालूम कर लेते हैं कि अब क्या होगी H ion की concentration. So it will be X is equals to 4.43 10 raised to the power minus 4 into 0.375 over 0.1, right? और X की वैल्यू अब आपके पास जो आएगी H ions, जो X एक्चुअली क्या है? H ions है, उसकी कॉन्सेंट्रेशन जो अब आएगी आपके पास वो कितनी आएगी? 1.66 10 raised to the power minus 3, right? This is what? Mole per decimeter cube. और जब आप pH निकालेंगे अब इसकी, तो it is again negative logarithm of H positive ions. So the pH will be 2.78. So you can see this बच्चों, ये practically भी prove हो गया है कि when you are actually adding salt over there, so the anions are going to be increased, and when anions are going to be increased, the equilibrium shifted towards left hand side, due to which you can say that the H ions are going to be decreases. When the H ions are going to be decreases, it is actually decreasing the acidic behavior and increasing the pH of the solution. Is that right, Bacho?
Yes, sir.
So this is a thing that you need to keep remember, right? And one more important thing I just want to add over here, you need to keep remember this as well for few parts. For example, if Ka is high, then dissociation of acid is also high, right? If pKa is high, right, then Ka is low and dissociation is also low, right? You need to keep remember these points. These are very important. Is that clear, Bacho?
Yes, sir. So pK means?
pK is you can say that it is completely opposite to the Ka. जैसे pH होती है ना नेगेटिव लोगैरिथम ऑफ H पॉजिटिव आयन, इसी तरह नेगेटिव लोगैरिथम ऑफ Ka जो होता है ना वो pKa होता है। ठीक है,
ओके सर।
चलें इसको लिख लें और यहाँ पर हमारा ये टॉपिक कंप्लीट हो गया है। अब हमें करना है बफर सॉल्व।